Hey, good morning, everybody. This is Mr. Ainsworth. We're going to get into a little sum and difference mind map for sine and cosine. And you know Ainsworth. Yeah, I'm a fan of mind maps, and we are going to try to develop one and see how far we can go on this. And so I've never done this before, so let's give it a shot. Now, you always have to know something, and the one sum formula that you have to know is the sum formula for sine, and it goes like this right here. So let's put this right in the middle. I'm using the variables alpha and beta from the Greek letter system here. So the sine of alpha plus beta. You have to know what that is, and then from that, believe it or not, you can get a lot of other identities, okay? Statements, mathematical statements that are true for all angles alpha and beta. Okay, we call these identities, okay, not formulas. Okay, so we know that the sine of alpha plus beta is equal to sine alpha times cosine beta. It has that alternating pattern here. Plus, all right, if it's a sum, it stays as a sum here, cosine alpha times sine beta. Okay, so you have to know your basic identity. And this right here, you have to memorize. So this one, let's make a little note. Okay, you have to know that. But believe it or not, from this identity here, you get everything else, okay? And it's actually quite simple. All right, so what I'm going to do is I'm going to branch off here, up here, okay, up there. Whoa, I don't know what happened there. Sorry. Okay, that was a little computer glitch. Okay, so let's try this again. All right, and let's develop the sine of alpha minus beta. So the sine of alpha here minus beta. All right, to get that, believe it or not, all you do is you substitute in negative beta in for beta, and then you got it, okay? Because this is equivalent to the sine of alpha plus negative beta. So again, you just substitute in negative beta in for beta. So let me write that out. Sub negative beta in for beta, and then to simplify, and voila, out pops out the difference formula. So here we go. I'm going to just substitute negative beta in for beta in the main identity right here in the middle. Okay, so here we go. I'm going to take the sine of alpha times the cosine of not beta, but negative beta. Add that to the cosine of alpha times the sine of negative beta. And then we simplify. All right, so what do we do? So what do we have? Okay, so here we go. I know that cosine of negative beta, that's an even function. Okay, we know that that's an even function here. I know that sine is an odd function, and I know what that means. So sine of alpha times the cosine of beta, they're equivalent. Cosine of negative beta is the same thing as cosine of beta because it's an even function right here. And then sine of negative beta, that's negative sine beta because it's an odd function. So I'm going to pull out the negative here and multiply it by cosine alpha times sine of beta. And I have my next identity. This is equal to the sine of alpha minus beta because I use the facts of even and odd. So you have to know some basics here from the past. Okay, I'm talking about this right here. Cosine of negative beta is the same thing as cosine beta because it's an even function. And then also sine of negative beta equals negative sine beta. That's why I pulled out the negative here because it's an even function. Okay, so now I have that one. So I have the second one. All right, let's get another one. Let's go down here. Okay, so now I want to get cosine of alpha plus beta. So let's generate this one. So cosine of alpha plus beta. What in the world is this? So I'm going to have to pull out the cofunction identities. Okay, everybody say cofunction. All right, and cosine is the complementary function of sine, so we know that it's equal to the sine of its complement of this angle in here. All right, so I need to use the cofunctions identities here. So use cofunction, and all my students know what I'm talking about here. Identities, I'm just bringing this in just as a little note. Okay, so the cofunction identities deal with its complements. So this is equal to the sine of its complement, and you know how to find a complement by taking 90 degrees minus the angle itself, which happens to be right here. It's called alpha plus beta. Okay, so you kick in your cofunction identity. and then you use it. Okay, so I'm going to distribute through the minus sign and kind of massage it a little bit here. So I got sine of 90 degrees minus alpha minus beta. And then all I do is regroup it and then apply the sign expansion that I know from previous, okay? The second one up there in the upper left of the screen. All right, so now I apply it. So here we go. Here's the sine expansion. So I take the sine of the first angle, which is 90 degrees minus alpha, times the cosine of my second angle, beta, right? Minus, because this is a minus sign right here. Look great. Let me highlight it right there. There it is. It's right there. It's a minus, right? So we got to use the equation number two. Let me label these guys. Equation number two up there. And then the main one is equation number one. Okay, just for referencing here, because I don't have one of those highlight bubbles that happens when you record. Okay, and then further on in this fraction, and take a look at up there at number two. I got to subtract cosine of alpha times the sine. Excuse me, I got distracted. Let me fix that. Cosine of the first angle, which is 90 minus alpha, so 90 minus alpha times the sine of the second angle, which is beta. Okay, so I use the cofunction identity to start, but now I need to remove the cofunctions. And so this portion right here, the sine of 90 minus alpha, well, that's the same as cosine alpha times cosine beta. Okay, so again, I use the cofunction identity there. Let me highlight what I'm talking about. These two things are equal, and you have to know your cofunctions in order to understand that. So if you're in my class, you do. If you're not in my class and you haven't done that, well, research the cofunction identities, and you'll see that's true. And then here, cosine of 90 minus alpha is the same thing as sine alpha, and then I got to multiply that by sine beta, and now I just derive my second identity, which is the cosine of alpha plus beta. Okay, so I'm going to refer to this one as equation number three. Okay, so I've developed three so far, one from memory and then two derived from the one from memory, which is right in the middle of the screen. Okay, now I need to get another one. So from this one here, instead of branching off the middle here, I'm going to draw an arrow from here, and then this one here gives me the next one here. Okay, so now I can get cosine of alpha minus beta, no problem. Because I know that cosine alpha minus beta just can be rewritten as the cosine of alpha plus a negative beta, which means all I have to do is substitute in negative beta, all right, in for beta, like I did on the upper left-hand corner of the screen when I developed equation number one. All right, so what is this equal to? So now I have to follow equation three. So follow that, it's right above it. Okay, so here we go. So it goes cosine, cosine, change sign, sine, sine. Okay, here we go. So cosine of the first angle, which is alpha, times cosine of the second angle, which is negative beta. All right, change the sign to minus, okay, and then sine of the first angle, alpha, times the sine of the second angle, which is negative beta. And then I simplify it. I know that I have even and odd functions. I know the cosine function is even, which means something, and I know the sine function is odd, which means something different. So what do I have? I have the cosine of alpha times cosine beta. That's a times right there, right? Because they're even. I know that the sine of negative beta is negative sine beta, so the double negative that you see here will change to a positive, and I get sine of alpha times the sine of beta. All right. So now I have my fourth equation here. I have cosine of alpha minus beta, and we're going to refer to this one as number four. Okay, so notice that the cosine expansions are different than the sine expansions. It goes cosine, cosine, change sign, sine, sine, whereas the expansions for sine, they alternate. So it goes sine to cosine, and the sine remains the same, and then cosine, sine. So they alternating pattern. Now, believe it or not, you can get all sorts of things from these guys. So let me see. So let me show you what I'm talking about. From the first identity, equation number one, I get one free here. I can figure out the sine of 2 alpha, believe it or not. It's called a double angle formula. Okay, not formula, identity. So double angle And the 2 there is what I'm talking about, the double angle identity. These are called identities, guys, not formulas. Okay, so here, how can I do that? Well, 2 alpha is just alpha plus alpha. So I know that this can be written as sine of alpha plus alpha. Well, then I just use the sine expansion. All I do is substitute alpha in for beta and go for it. So I'm going to write that down. So substitute alpha in for beta and then simplify. So what do I have? I get, now look at equation number 1 in the middle of the screen. Everywhere I see beta, I'm going to substitute an alpha. So I get the sine of alpha times cosine of alpha, right? Plus cosine of alpha times sine of alpha, because I put an alpha in for the beta. And notice, guess what? These are the same terms, guys. I've got 2 of them. So I just write it like that. 2 times the sine of alpha times cosine of alpha. And there's your double angle formula, all right, for sine. We're going to call that equation 5 since we just developed that. Okay? That right there. I'm talking about this one right here. That is your double angle formula for sine. Now, how can we get it for cosine? Well, guess what? We use the one that has the sum. Okay, this one right here, equation 3. That one will give you your double angle formula for cosine. So let's develop that. All right, so here we go. So we're going to start off with the cosine of 2 alpha. How do I get that? Well, I know that 2 alpha is the same thing as alpha plus alpha. So if I do the same thing as what I just did to get the double angle formula of sine, then I should be able to do this. All right, so this is equal to, now remember the cosine expansion here, it goes cosine, cosine, change sign, sine, sine. So here you just follow the pattern. So cosine of alpha times the cosine of alpha. Remember, we're substituting alpha in for beta. I better write that down. Substitute alpha in for beta and simplify. So, and then we change the sign, minus, all right? Sine of alpha times the sine of beta. Oh, excuse me, alpha. Got to substitute. Okay, so what is this equal to? Well, cosine alpha times cosine alpha is nothing more than cosine alpha squared minus sine squared alpha. And that's equal to cosine of 2 alpha. So there's your double angle formula. We're going to call that equation 6. So now we have 6 identities. Okay, now this gives us another one. Okay, I know that every time I see cosine squared or sine squared, that's your Pythagorean identity. Let me make a little note of that over here. Pythagorean, I'm just going to, it's floating around here somewhere. So Pythagorean identity here that you guys already know from the prior lessons here. Pythagorean identity, that goes by cosine squared alpha plus sine squared alpha is equal to 1. Which means, guess what? Sine squared alpha, if you want to simplify that, is equal to 1 minus cosine squared alpha. It also means cosine squared alpha is equal to 1 minus sine squared alpha. So this is from our prior video here, so I'm just going to, this goes off to the side, and it's floating in space on the mind map right there. But hey, guess what? What I'm going to do is I'm going to bring it in here and rewrite it. Because what happens is, if you want to zoom in here, I can replace this. I can get a new double angle formula here for cosine of 2 alpha, by simply replacing cosine squared alpha with its equivalent, which is 1 minus sine squared alpha, all right, minus this other sine squared alpha. And if you simplify that, you get 1 minus 2 sine squared alpha. Okay? So that's another identity. Or I could have made a different substitution. So right there, I just replaced cosine squared alpha, which is equal to 1 minus sine squared alpha, and I simplified it. But if I did the other one, if I did it another way, if I substituted right here for sine squared alpha here, I can replace 1 minus cosine squared alpha with it. So let me start over here. I'm going to write down the original identity. So cosine squared alpha minus sine squared alpha. I'm going to leave cosine squared alpha as it is, but I'm going to substitute what sine squared alpha is which I know it's 1 minus cosine squared alpha. Then all I have to do is distribute through. So I get a minus 1 plus cosine squared alpha here. And then you simplify that, you got cosine squared plus cosine squared. Well, guess what? That's a 2 cosine squared alpha. All right, it's an alpha there. All right, minus 1. So I'm going to bring this down just so you can make a point here. This is cosine of 2 alpha. This is your double angle formula. And the first one up there, I'm going to rewrite it here. Cosine of 2 alpha in the beginning there was originally equal to 1 minus 2 sine squared alpha. So really we have two more identities here for double angle identities for cosine. And guess what? We should call those equations 6 and 7. So that's equations, nope, 7 and 8, sorry. Okay, 7 and 8 because there's two of them. Look at that, my friends. Look at that. Ooh, boy, that's awesome looking. Okay, so I have all 8 identities. I've got the sum and difference identities. I've got my double angle identities. And I even threw in Pythagoras in there because I needed it, right? Because Pythagoras helps me develop the cosine of 2 alpha, which are called the double angle identities for cosine. And there's half angle identities as well. I'm not going to put it in the mind map here because it's just too complicated and we're not ready for that yet. But this is a cool way to put everything all together. And if you can do this, like I just demonstrated off the cuff, you know your stuff, guys. Okay? Trust me, you know your stuff. So this is one of the best ways to study other than just direct application with real numbers, okay, which is, what we do in class here on day 2. All right, but doing this at home will get you to really understand the connections between these and how they're developed and then mastering all the prerequisite identities that you need to know, like even and odd identities and the cofunction identities, yeah, to develop new identities. So practice this mind map on your own. And I'll tell you what, I'll put a challenge out there. If you can do this on your own and come in and do this on the main whiteboards in class, I'll tell you what, I will take you at any test score that we have and raise it up by 10%. All right? You'll go from an 80 to a 90 or a 90 to 100. I'll do that for you if you can do this. Because if you can generate this, that says something. All right, so the challenge is out. Let's see who takes it. Bring it on. All right, this is Aynesworth. And again, I work at Great Oak High School here. My name is Mr. Aynesworth. Been teaching since '92, so quite a while at Great Oak High School in the AP Pre-Calc program, but also the Financial Algebra program. And I teach the other courses too, but that's what I'm focusing on this year. So make yourself proud, work hard, study the right way, like make mind maps here and get really good at it. And I'll see you in my next lesson or video and hopefully in class. Take care. Bye-bye.